We have a particle that's moving due north at 5 meters per second, accelerated at 5 meters per second squared due 53 degrees east of north. Alright, let's try and draw this first. So we have again a particle that is moving due north this way at 5 meters per second. So again, it's 5 meters per second along the vertical. It's accelerated now at 5 meters per second square due 50 degrees east of north. Well, remember, this is north and this is east. So 53 degrees east of north will be somewhere this way. This is 53 degrees. So east of north is going to be here. So 5 meters per second square along this direction. That is 53 degrees. Okay, and we have to again calculate the speed of the particle after 5 seconds first, and then we have a second question which we'll look at a little later. The difference in this question is that in the previous question it was a little easier, where the velocity and acceleration were in two perpendicular directions. So in one direction there was no velocity, in one direction there was no acceleration, and the other direction there was no initial velocity. Everything was simple. But now the acceleration comes at some angle, about 53 degrees this way. So what do? Well, I have taught you decomposition of vectors. So what we'll do is we'll take this acceleration of 5 meters per second square and we'll write down its component along the vertical, which is along the north direction, and its component along the horizontal, that is along the east direction. Let me write the components using some other color. So let's say I will use blue for that. Okay, now remember, the component along 53 degrees, this is the adjacent component, that's going to be 5 cos 53, which I'm going to write here. And the component along the horizontal is going to be the opposite component, so it's going to be 5 sin 53. Now cos 53 is given over here, it's 3 by 5, and I always like to remember that, so let's just write down what 5 cos 53 is going to look like. 5 cos 53 is going to be 5 times 3 by 5, so that's going to be just 3. So what you understand is 3 meters per second square is the acceleration along the y direction, along our north. And similarly along the along the east, we have 5 sin 53. That's going to be 5 times 4 by 5, right? Because if cos is 3 by 5, then sine must be 4 by 5. We discussed this before. That must be 4 meters per second squared. So I think now the picture is quite clear. We can solve this problem now by again looking at two different directions. Let's look at the vertical first. In the vertical, I have the initial velocity. I'm going to consider up as positive. Initial velocity is 5. I'm not going to write the subscripts, it's understood. Acceleration along the vertical is 5 cos 53, that is 3. And we are asked after a time of 5 seconds. Therefore, v equal to u plus at, 5 plus 3 times 5. So v is going to be 5 plus 15, so 15 plus 5, that is 20. So we have found what is the velocity in the vertical after 5 seconds. Now let's calculate in the horizontal. Notice in the horizontal there is no initial velocity, just like what we did in the previous problem. The entire 5 meters per second square is only directed along the north, along the vertical. There is absolutely no component along the horizontal. But notice that the acceleration now is not 5. The acceleration is only 5 sin 53, which is just 4. Time taken is 5 seconds because the time taken is the same, and so we can now calculate what the final velocity in the horizontal is going to be. It's u plus at. That is 20. Oh, that means finally we're going to have a velocity along the vertical this way of 20, and we're going to have velocity this way of 20. Therefore, if you combine them together, we're going to get 20 root 2, Pythagoras theorem. So our final answer is, our speed after 5 seconds is 20 root 2. And look at the direction. if this angle is 45 degrees, so it's going to be due 45 degrees east of north. Looks like a complicated problem, but once we divide it into two perpendicular components, it becomes easy. Alright, now let's try and tackle the second part of the problem. The second part of the problem is we need to calculate the velocity when the velocity vector makes an angle of 37 degrees with the north. Okay, so let's redo this. Let's draw this somewhere over here. Here is our initial condition. You have initially, so I'm going to call it point as A now. That is 5 meters per second. And then we also know the decomposed version of the vector, decomposed version of the acceleration. The acceleration along this direction. But how much was that? That was 5 cos 53, that was 3. So this is 3. Okay. And this was 4. Now clearly, this particle is going to end up going in a curve, somewhat this way, because of the acceleration and everything. And it's now given that we are interested in calculating the velocity when it makes an angle of 37 degrees with the north. That means when this angle is 37 degrees. We need to now find out what V is. Time is not mentioned. Let me call this as point B. What can we do? Well, the first thing we can do is we can just decompose. We know the final velocity in the vertical and the horizontal. In the horizontal, it's going to be V sine 37 degrees. And sine 37 is going to be, if you remember that triangle, 53, 37, it's going to be 3 by 5. So it's 3 by 5 V. And in the vertical, along the north direction, it's going to be V cos 37. That's going to be V times 4 by 5. So we now have two unknowns. That is, we don't know what the time it takes to go from A to B, and we also don't know what final velocity V is. Hey, but you know what? We can build two equations, one in the horizontal and one in the vertical, and solve them. Alright, so let's do it. Let's do the vertical first. For whatever I do, I'm going to choose upwards positive, and I'm going to choose right direction as positive. So, and I'm going to do the physics from A to B. Usually we should mark the point so it becomes easier to understand. I did not do that in the previous ones, but let me do that from now onwards. Okay, so the initial velocity, that's at point A, is going to be 5, acceleration is 3, and final velocity is V cos 37, that is, we have already found out, that is V times 4 by 5, and time is T. So what equation can we use to connect them? Well, 4 by 5V is equal to U plus A times T. So if we, 15T. Okay, so that's equation number 1 for us. Let's now go into the horizontal and build another equation quickly, shall we? So from A to B, initial velocity in the horizontal is 0, remember that. Acceleration is 4. And final velocity is going to be 3/5 of V. Therefore, division over here. So 3V by 5 is initial velocity 0 plus AT 4T. Oh, my plus sign and T looks identical. Alright. So the equation here is going to be V equal to 20T by 3. Ooh. What I can do, no, let's not do it for V. Let's calculate T from this equation. Let's substitute in the other equation. So T equal to 3V by 20. And let's substitute this guy over here. So 4V equals 25 plus 15 times 3V by 20. So 5 3 times, 5 goes 4 times. So we have 4V equals 25 plus 9V by 4, and now we are almost done because this is just algebra. Let's calculate that quickly, shall we? So we have 16V equal to 25 4 is 100 plus 9V, or we have 7V, oh, some horrible numbers we're getting, is equal to 100. So V turns out to be 100 divided by 7. So that is what? 7 one times, and you get 30. So 7, let's see, 7 4s are 28, and you have 20, 7 3s. It's roughly 14.3 meters per second. That's our answer for the second question. So notice that the velocity has increased. That makes sense because it's continuously being accelerated. So over here, this number is going to be 14.3. I hope you have understood how we solved this problem. It was an amazing problem and just goes to show how powerful vectors are. More problems will come in the next episode. Stay tuned.